Hello, this is Kurt in the math department. On this video, we're going to look at expressions. This is covered in section 1.2 and 1.3 of our textbook, and we're going to learn what an expression is versus an equation, and we're also going to learn how to evaluate expressions and simplify expressions. So let's get started. As usual, I'm going to move fairly quickly through this, so if you don't quite understand something, make sure you pause and rewind, and when we get to the problems that you get to practice, pause the video and then start it back up before we give you the answer. So here we go. Expressions. What is an algebraic expression? Remember, an algebraic expression is a meaningful collection of numbers, variables, which are the x, y's, a's, b's, and operations. Remember, operations add, subtract, multiply, divide, versus an algebraic equation. We're going to be working later in this course with algebraic equations. An algebraic equation is a statement of equality, so there's an equal sign involved here, between two algebraic expressions. Let's look at some examples. Identify whether each of these is an expression or an equation. So if we look at this first one here, do you see an equal sign? Nope, therefore it is an expression. So if we go down through each one of these, what the one telling sign on each of these is there a number and a variable and or an operation? Then it could be an expression. If there's an equal sign, then it's an equation. In this case, there's no equal sign, so it too is an expression. Now on C, clearly there's an equal sign. C equals 2 pi r. So this would be an equation. Going quickly now through D, there's no equal sign. It's neither. Why would it be neither? Well, you see here we have a multiplication and we have a subtraction, and there's no number or variable in between, so this isn't written in a proper format to be an expression or an equation. Now below, this is times -2. That one is an expression. There's no equal sign. And the last one with the equal sign, that very definitely is an equation. So that's how you can tell them apart. We'll work with equations later. Today we are looking at expressions. The first question is, write an expression for each of these. In other words, there are 28 coins of nickels and dimes. Let x be the number of nickels. Write an expression for the number of dimes. We did this a little bit in the introduction, but see which one you think is the right answer that would represent the number of dimes. I'll give you a moment. You can pause. Welcome back. Which of these did you think the right answer is? The correct answer is 3. If you have 28 total coins and x is the number of nickels, then 28 minus x would leave the number of dimes. To evaluate expressions, this is something we do quite often. You substitute the given value for each variable and then use the order of operations to simplify. So for an example here, we start with an expression of c squared plus 4 times the quantity d minus 2. So you have c squared plus 4 times d minus 2, and they give us values. They give us values for c and they give us values for d, and so what we need to do is make sure that we put the proper value into the proper locations here, and then we use the order of operations to simplify. So for example, in this case, starting with our expression, when we put the -2 in for c, remember c squared means literally c times c. So we have to use parentheses to say that we're going to take all of c, in this case -2, times itself, so -2 squared, and then d, we replaced it with the value -5. Now using order of operations, we would see that the -2 squared means -2 times -2, which is +4. We have to do what's inside the parentheses first, so -5 minus 2 is -7. Simplifying that further, we do the multiplication before we do the addition, so 4 times -7 is -28. Finally, we do the addition to get our answer of -24. So there's an example of evaluating expression. We're just putting the values in for the proper variables. I'll give one for you to practice here. Our next question, evaluate 7x over y if x equals 2 and y equals -5. I'll give you a chance to do this one, so you can pause and then come back for the right answer. Welcome back. Which of these did you think was the right answer after evaluating that expression? You take 7x, you put the value of 2 in for x, -5 in for y, 7 times 2 is 14, and you get negative 14/5. The truth is all of these are correct. This is a common question students have. You started off with the negative in the bottom with the 5, then we wrote it as the negative on top. Does it really matter whether you have a negative in the numerator, negative in the denominator, or the negative sign out front? The truth is it doesn't matter. These are all equal and equivalent, and if you think about it as a negative number divided by a positive number, it'll always end up being negative. So it doesn't matter. A positive divided by negative is also negative. So all three of these are equivalent. Let's give you another one to practice then. Evaluate the quantity C plus D times the quantity C minus D if C equals 2 and D equals negative 5. I'll give you a chance to evaluate this, so pause your video and come back for the answer. Welcome back. Which one did you think is the right answer? To evaluate this, we're going to put 2 in for C. You can see that we have 2 here and 2 here. We put negative 5 in for D here and here. This is where you have to make sure, take care of your signs, minus a negative and all those proper sign management skills. And so what we end up with is 2 plus negative 5, that equals negative 3. 2 minus negative 5, that equals 7, because 2 plus 5 is 7. Then when we multiply those, we know that negative times positive is negative 21. So the correct answer is 3, negative 21. I hope you got that. So here's our last one to evaluate. We have a formula. A formula is an equation that allows us to compute a certain quantity. In this case, it's the area of a trapezoid. The area equals 1/2 times the quantity of the large base plus the small base times its height. So they give us the values for the large base is 20 inches, the small base is 14 inches, and the height is 9 inches. Find the area. So it's really just a matter of, again, taking these values and putting it in place of the variables. So here we start with our expression. We substitute in the variables. Now again, order of operations, we do parentheses first, and then we have multiplication, and we take it left to right. So I would start with 1/2 of 34 and get 17, then the 17 times 9 and get 153. So hopefully your answer was 153 square inches. Not inches, square inches, because we always have to keep mind of our units. Example 4. Determine which are like terms. So we're going to now hopefully start simplifying expressions, and to do that we have to combine like terms. So the first thing we're going to work on is whether or not they're like terms. Expressions are like terms if they share exactly the same variable and the same exponent on that variable. Here we have a term with x. This one does not have a value of x, so these are not like terms. Here we have variables x and y. They both have variables, but they're not the same variables, so they're not like terms. Here we have 5x and 7x squared. While they're both x's, we can see that this one has an x squared, the first one doesn't, so they're also not like terms. And then lastly here on these, clearly one's 7x to the first, the other one's 5x to the first. They would be considered like terms. So now we have to consider all of those elements. So on the next example, we have m squared n, m squared n. They are exactly the same, so they're like terms. The next one has m squared n again, but does it combine or look exactly the same as m n squared? No, they're different because of which variables being squared. Lastly, is the y squared x the same as x y squared? And the answer is yeah, they're like terms. They switched order, but you see it was the y being squared, and it's being squared in both terms, x to the first, x to the first. They're like terms. Now, why is that important? Because to simplify expressions, we have to be able to simplify if they're like terms. So in this case, what we're doing is we're subtracting. And what are we subtracting? We're subtracting m squared n and 5m squared n. First of all, are they like terms? Yes. How many m squared n's do we have here? This is a common question for students, and if there's not a coefficient out front, it's always assumed that that's at least that you have one of those. So what we really have here in this case is we have 1 m squared n minus 5 of m squared n. So one of these minus 5 of those gives you negative 4 of those. So here's a few other examples. First of all, are these like terms? And if the answer is no, you cannot combine them. so you have to leave that one alone. What about the next one? Y squared x, xy squared. We talked about the fact even though they're in a different order, they are the same variables with the same exponents. So you have 7 of these plus 1/2 of those, and so you get 7.5 or 7.5 equivalent. You're just adding up the quantity of those. Now you see, recognize the things don't change, just the quantity of them changes. And then the last question for you is, let's add these expressions together. Now that you understand about combining like terms, here we have one expression we're going to add to this expression. Go ahead and pause the video and see what you get. Okay, welcome back. So we're adding, let me get my pen back here. We're adding these expressions. Therefore, we just simply take them and put the addition sign between them. Now these parentheses are here primarily to show that we have one expression added to another. It's just showing you that you have two separate expressions. Now when we go to add, we can remove the parentheses because addition isn't going to change any of the signs of the second expression, so it stays the same. But in this format, you can look and say, okay, which of these are in fact like terms? And hopefully you realize that the 6 will be able to be combined with the 40 because they're both constants. In the same way, both of these terms are x squared, so we can combine those. So when we do that, negative 15x squared plus 1x squared, so negative 15 plus 1 is negative 14x squared. Combine those like terms. Then the 6 plus the 40, we always grab the sign in front of the number. 6 plus 40 is 46. So hopefully that's the answer that you got. The correct answer is negative 14x squared plus 46. Let's look at just one more. And this is one that often challenges students, so I wanted to include it. It's simplifying the expressions when you're subtracting, especially when it's given this way. The problem reads subtract 6 minus 15x squared, and here's the hint and the key, from x squared plus 40. See if you can do that. Pause the video and come back to see if you got the same answer as I did. Okay, welcome back. Let's see what we get for an answer. The first thing we must make sure we do correctly, especially when it's worded this way, when it says subtract from, that means we're taking this expression, starting off with that, and we're subtracting from it this expression. So when we write it out, make sure you put it in this order. Once you have it in this order, the second thing with regards to subtraction we need to be aware of is when we're subtracting an expression, we're subtracting all of it, which means we're subtracting this term and we're subtracting this term. So this expression applies to both. And if you remember last section, we talked about this briefly. So when I go to simplify it, I leave the first expression alone, but this subtraction then creates a subtraction minus 6, as you'd expect, but this subtraction of negative 15x squared, subtracting a negative becomes addition. So this becomes plus. Now it's a matter of recognizing like terms. Here we have like terms, 1x squared plus 15x squared, and then we have our constants, which are also like terms that we can combine. So when we do that, 1x squared plus 15x squared is 16x squared, 40 minus 6 is 34. And hopefully that's the answer you got, answer number 1. I hope this review on evaluating expressions and simplifying expressions is helpful for you.